So in this video, we will deal with our midpoint formula. Okay, so what is our midpoint formula? So M P, which means midpoint, is equal to the average of our x1 and x2 divided by 2 and y1 plus y2 divided by 2. Wherein x1 and x2 and also y1 and y2, or x1 and y1 and x2 and y2, are the endpoints of a line segment, right? So in order to prove to you this one, I would use some algebraic techniques and of course our distance formula. So let's say I have a point or a line segment wherein I have my first point as my x1 and y1 and my second point as x2 and y2. Okay, in which we will get the midpoint, wherein I would refer my midpoint as my xm ym. Okay, so since our midpoint is equidistance to these two endpoints, therefore I may say that if I would create my d1 here and my d2 here, I may say that my d1 must be equal to my d2 since they are my midpoint, since xm and ym is my midpoint. Now, using my distance formula d at d1 in order to solve for my d1, or in order to get the value of my d1, I may say that this is just equal to the square root of xm minus x1 square plus ym minus y1 square, and my d2 is equal to square root of my x2 minus xm square plus y2 minus ym square. Since my d1 and d2 are equal, therefore I may say that I have square root of xm minus x1 square plus ym minus y1 square is equal to square root of x2 minus xm square plus y2 minus ym square. So from here I can get, or I can remove my square root already by raising both equation by 2. From here, I will have my xm minus x1 square plus ym minus y1 square, which is also equal to my x2 minus xm square plus y2 minus ym square. Of course, the next thing to do is to square both sides, is to perform the basic operation in our equation. So from here, I will have xm square minus 2xm multiplied by x1 plus x1 square plus ym square minus y1 2y1 multiplied by ym plus y1 square, which is equal to x2 square minus 2xm x2 plus xm square, and we have y2 square plus 2y2 ym minus, I should say, plus our ym square. Now from this equation, we can see, or we could group all values with x and all values with y. So from here, I would group my x values such as xm squared minus 2xm x1 plus x1 square, and I will transpose my x2 square minus 2xm x2 plus xm squared. Notice that I did not change any sign because I've already put my negative here. Of course, next we have plus ym squared minus 2y1 ym plus y1 squared minus y sub 2 square minus 2y2 ym plus ym square equals 0. Okay, next is that after moving or transposing my equation, is that the next thing to do is to simplify that one. So from here, you can see that I can cancel out my xm because xm squared minus xm squared is 0. Then after that, you will see that we have negative 2xm x1 plus x1 squared minus x2 squared plus 2xm x2, of course, plus we have ym squared minus 2y1 ym plus y1 squared plus y1 squared minus y2 squared plus 2y ym minus ym squared equals 0. Take note that ym squared minus ym squared will be equal to 0. The next thing to do is, of course, to group our y's and x, and after that you would find for the value of xm. So first is that I will be manipulating in my x values in order to find for xm, solving for xm. So from here, since this must be equal to 0, I will have all values in xm and xm grouped together. So we have negative 2xm x1 plus 2xm x2 is equal to, I will transpose x1 minus x2 to the other side, so therefore x2 minus x1, so x2 squared minus x1 squared. The next thing to do is, of course, to factor out my 2xm. So 2xm, so I will have negative x1 and x2, so therefore I will also rearrange my equation. So x2 minus x1 is equal to, take note that x2 minus x1 is a difference of 2 square, so therefore I will factor it as x2 minus x1 multiplied by x2 plus x1. So in this, you will see that we could cancel out your x2 and x1 because that is equal to 1. So the remaining term will be 2xm is equal to x2 plus x1, so xm is equal to x2 plus x1 all over 2. This is for our point xm. Now, to solve for our point ym, solving for point ym, we will undergo similar procedure, solving for ym. So since we have already eliminated these two ym here, now let us recombine those variables with ym, or those terms with ym, I should say. So from here I will have 2y2 ym minus 2y1 ym is equal to, I will transpose my y2 square minus y1 square. Next is, of course, to factor out my 2ym, so therefore y2 minus y1 is equal to, factoring my difference of 2 square, which is equal to y2 minus y1 multiplied by y2 plus y1. So from here I will have my ym, which is equal to, cancel out my y2 minus y1, I will have y2 plus y1 all over 2. Okay, so this is my algebraic derivation of my midpoint formula, in which you can see that we have proven that the midpoint is equal to x1 plus x2 all over 2 and y1 plus y2 all over 2. Okay, so that would be our midpoint formula.